So today we will just start or continue wherever we left off. Later. So yesterday some of you were absent. I'll just give an overview, quick overview. You can see the screen, right? So everyone can see the screen. Any glitches?
Yes, ma'am.
Okay. Okay, so yesterday we were discussing about simplified data encryption standard. So your normal data encryption standard is like 56-bit, 60, 56-bit encryption model, and this simplified data encryption standard is your for 10-bit key and 8-bit text. So in simplified data encryption standard, it's like a standard encryption system. It's like modern one. We are going to just learn about the simplified one because it is just same as your normal DES, that is data encryption standard, and that one the process is same, exactly same, just that that one is like for 56-bit, and simplified data encryption standard is for like the simplified version, of course, and it's for like educational purpose. So but in real life people uses normal DES, which is a 56-bit one. So simplified model is a block cipher. I already mentioned block cipher means where we replace substitute a block of plain text into cipher text. And your cipher steam cipher was when we replace one bit at a time. Okay, so it's a symmetric cipher. That means same key will be used in both encryption and decryption process, and this algorithm has two rounds. Okay, so for encryption it takes 8-bit block plain text, then takes 10-bit key and produces 8-bit block cipher text. That means number of uh, bits in a block of plain text is same to the number of block of ciphertext. Okay, and for decryption, it will be same. It will be just the reverse process. So this was the whole model for DES. So there will be an encryption. Encryption mainly consists of 5 functions. IP is initial permutation. FK is a complex function which mainly involves like permutation and substitution operation. It's also known as Fistel block cipher, which I mentioned yesterday. SW is just uh, switching or swapping half. Okay, you will learn about these functions one at a time. I'll skip this thing. So yesterday we um, start from the key generation. So for DES to create ciphertext, first of all we need to generate key. Now in case of SDES we need two keys because it has two rounds. So this was the general form of your ciphertext You can say just formula. So for encryption, for key generation, it follows these steps. So 10-bit key will be used first, which will be put into a P10 table. So remember, yesterday I told all of this permutation like P8, P10, P4, there will be different tables, and these are fixed permutation. We cannot change it. So what they do, they just number the bits of a binary key, then it just permutate the place of those bits. Okay. So these are just fixed permutation. So initially all bits will be like, we can number it 1, 2, 3, 4 up to 10 because it's a 10-bit key, then we can just permute. But this is fixed one. Okay. So at different level we are going to use different tables. So for key generation, first task is the key generation. Yesterday we completed the key generation task. So for key generation, we are going to use 10-bit key. After that, we will put in P10 table. P10 table is this one. Okay. So I'll suggest both, means all of you just take pen and pencil, not pencil of course, pen and paper with you guys. Uh, Otherwise it will be difficult to understand. So everyone has paper and pen with you guys. Okay, so after P10, we are going to divide the 10-bit into 5 bit. Okay, then on each half, we are going to perform a left shift by 1 bit. Okay, then those two halves will be combined again and put it in P8 table. P8 table is here. So after that, in P8 table, from the 10-bit, we are going to get an output of 8-bit. You can see the first 1 and 2 bit will be removed in P8. Okay, it's like select and permute. So after P8, again the input to the P8 will be again those two halves will be left shifted by 2 bit. Then again this will be combined and put it in the 8 bit. So in this way we will get two keys. Okay, so I have also mentioned all the steps for key generation, and we followed the key generation step and came here. So this was your SDES. So for key generation, first I took this key, which is a 10-bit key. Okay, and following the steps, first we are going to put in a P10 table. So in P10 table, see this is 10-bit key, which we just give numbers 1 to 10. After that, the expected output will be just permutation according to this P8 table. Sorry, P10. It's 3527410 198. Okay. So here we did the same. So first I just wrote this 35274 these numbers, then I just replace. You can see number 3 is 1, so I put it 1. 5 is 0, so I put 0 here. 2 is 0, I put it 0 here again. For 7 is 0, put 0 here. And 4 is 0, 0. Then 10 is 0 again. 1 is 1, 9 is 1, 8 is 0, and 6 is 0. So this is the output after P10 table. So after that, we are just going to split into two halves. So after splitting, this 10-bit number will be a 5-bit number. So in this 5 bit on each half, we are going to perform a left shift by 1. Okay, so after splitting, this is the output. One half, left half is this one, and right half is this one. So you have to apply left shift by 1 bit. So it will be like circular shift. So if you shift it by 1 bit, this one will come to the last point and this will be just shifted forward, right? The same thing we did in the right side as well. It just shifted to one bit. So this 0 came here and these two came in front. So after this left shift, we are going to combine it again. Okay. So after combining each half after left shift, we will just put in P8 table. So again, we are going to just put numbers is the same output. We will just number then generate a P8 output. So P8 table you will get just here. So you just need to follow it. So here also I just number it 63748. These are the expected output, and after this we just got this key. So after P8 we will get first key. Okay. So there are two keys are needed. So we got our first key. So after that what we are going to do, remember in after last shift we got two values, then that same values will be left shifted by 2 bit now. So initially your value was 0001, then it is shifted here means by 2 bits. So after left shift by 2, this one will come here. Okay. Output of P18, it's not P18, it's P8. See, your bit is 10. Okay, 10 bit number. This is the output after combining the left shift of each half. Okay, so this is your expected output from your P8 table. Okay, it's 6, 3, 7, 4, 8, 5, 10, and 9. So I just wrote these numbers first: 6, 3, 7, 4, 8, 5, 10, and 9. So after that I substituted. For 6 it's 1, 3 means 0, 7 means 1, 4 means 0, 8 means 0 again, then 5 means 1, 10 means 0, and 9 means 0. Okay, so that's how we get the output from the P8 table. So this is our first key. Okay, then what we are going to do, we use the same left shifted by 1 bit output value again. We are going to split it this actually, but it's same. So we will again left shift by 2 bits. So this one will come here and whole thing will be just left shifted like circularly. So after left shift by 2 bit, we will get these two numbers, then we will again combine it, then we will again put it into our P8 table. Okay, it's again 1 to 10, then again same 6, 3, 7, 4, 8, 5, 10. We are just going to see the numbers. 6 means 0, 3 means 1, 7 means 0, 4, 0. So this output is our key 2. So for the key generation, we are going to just take 10 bit binary key. Then first we will put in P10, then we will split it, then left shift on each half separately, then we combine it. Okay, then we put it in P8 table, then whatever we get, that's our key 1, that's our first key, and the result of your left shift 1 key, we will again split it, is this one, but it's same generally. So we will just left shift by 2, then we will again combine it, then again put it in 2. So how we are generating two keys? First P10 split, left shift by 1, put it in P8 table, then second key will be generated from this combination, again split, then left shift by 2, again put it in P8 table. So after this, from a 10 bit key we are generating two keys of 8 bit. Okay, okay. Okay, now we will start. So write down these keys, okay? Or just write the process as soon as possible because I'm going to need this key for your ciphertext generation. And ciphertext generation is a longer process. Okay, so write down these keys. Later, when I ask, then you have to tell me. সবে লিখি লৈছা? Okay. Let me know when you guys are done, okay? Okay, done. Rupam done. Sahid done. Arindam done. Okay. Okay, so what is our encryption process? Okay, okay, encryption is much more complicated, but it's just repetitive work. So for encryption process, first we are going to take an 8-bit plain text. Okay. Then after that, we will do initial permutation. So initial permutation is again a table which will have like expected output already. So you just need to put it in that table. So after doing the initial permutation, we will again divide into two halves, left and right halves, which will be of 4-bit each. Then we are going to use the right half, then put in expand EP table. EP means expand and permute. So from this 4-bit, we are going to generate an 8-bit output. Okay. Then this 8-bit output will be XORed with the first key we use. Your key is 8-bit, right? Then from for this 4-bit key, we are going to generate 8-bit. So we are going to XORing it. After XORing, we are going to again divide into two halves. And each of these half will be put in S boxes. Okay. S boxes means your left half will go to S0 and right half will go to S1 boxes. After that, we will get 2 bits from S boxes. So these 2 bits will be combined again and will put in P4 table. P4 is again a fixed bit 1. So in P4, after P4, we are going to use this left half or the EP XOR again and we'll get 4 bit 1. Then we are going to shift or swap both half. Okay, I'll just go with the thing. So just that the same process will be done in the next phase. So there are two FK process. Okay, FK means your physical block. It's like a bit complicated. So just be attentive. So let's see the first step. So first step is that put 8-bit binary plain text into initial permutation 8 table. Just don't confuse, okay? These numbers are all fixed. We cannot change anything, okay? So again, we are going to number up these things, our bit, then permute the bits. Then we will break into two halves. Then each half will consist of 4 bits. The half will be right and left. Then we are going to take right 4 bit and put it in expand and permute table. Okay, from this right output we will get 8 bit. So you can see the number we are going to put it like 1 2 3 4 5 6 up to 8, but there are only 4 bits. So for the permutation only the numbers used are 1 2 3 4. Okay, so okay, just let's go with the example. I'm going to clear this canvas. Okay, now we will start our encryption process. So let's take our plain text is it will be binary again. Zero. Okay, so this is our plain text 0, 1, 1, 1, 0, 0 and 1, 0, which is our 8-bit plain text. Okay, so first what is that? We need to put in initial permutation 8-bit table. Okay, IP8 table we will use. So first, so your input is what? This one again. You go just number it 8. Okay, 8-bit. So our output is what? Should be 26314,857. Okay. Okay. So what is our 2-bit? It's 1. 6 means 0. 3 means 1. 1 is your 0. 4 is 1. 8 is 0. 5 is 0 and 7 is 1. Okay. So the output is 1 0 1 0 1 0 0 1. So what's the next step? We are going to split it into two halves. So step 2 is split. It's a 8-bit. If I split it, it will be just 2 halves, 4-bit, 4-bit. So we are just going to take this right half, okay? And we are going to use this left half later, okay? So your right half is what? 1001. Okay. Remember, after that we will put it into E5 EP table. See, take the right 4 bit and put them into EP table. So for EP table, just number it similar way. Now we are going to use EP, expand and permute. Okay, so our input is 1001, but we are just going to number it like our output will be 412, 323 and 41. Okay, so 4 is 1, 1 is 1, 2 is 0, 3 is 0, 2 is 0 again, 3 is 0 again, 4 is 1 and 1 is 1. So this is our output after expand EP table. Okay, so let's see what's the next step. Now we just take the output and XOR with the first key or the key 1. Okay, so let's do that first. So we need to XOR this with the first key. Key 1. So your values will be 1. So tell me the first key. And didn't get the part. How come it's 260? It's fixed permutation. It's from this table. It's fixed permutation. The permuted bit our expected output will be 260,148.5. Okay. Input we are just going to give numbers. The output permutation bits are already fixed. It should be 260,148.5. Same for all the tables P10, P8, EP, all the tables, all the permutated bits are fixed. Okay. So what's the key one?
101000100.
0, 1, 0, 0. Okay. So we are just going to XOR it. So how XOR gate works? When do we get a 1 and when do we get a 0?
Maybe 1 1 is equal 1 and 0 0 equal 1. বাকীবিলাক 0 আছিল নেকি?
যদি mismatch হয় তেন্তে 1, যদি same bit হয় then 0. Okay, so 1 1 হলে 0, 1 0 mismatch, so it will be 1, it will be 1 0 0, it's 1 and it's 1 and it's 1. Okay, so this is our result after XORing. So what's the next step? We are going to split it into two halves. So once again split the output of XOR bit into two halves, and each half will consist of 4 bits. Now each will put in S boxes. Okay, so S boxes give her, it's it's again a fixed bit boxes. These are in matrix form. Okay, so 4 bit we will give it to two boxes. One is for S0 and one is for S1. So these are again just fixed bit. Just that the condition is S box considered as a matrix, and input used to select row column, and selected element is output. Then we have a 4-bit input, right? Then we can just number those bits. Just that for the 4-bit input, number 1 and number 4b will specify the row, and bit 2 and bit 3 will specify the column. And after that, we will get 2-bit output. Okay. And S boxes is like this one is again fixed matrix. This 0, 1, 2, 3 is the numbering for your column, and again for this one is the numbering for your rows. Okay, so this is again a fixed permutated box 1032. So this one mainly we use this one. This is nothing but the binary value of this one. Okay, so binary value of 1. See the binary value of 1, 0, 1. Binary value of 0, 0, 0. Binary value of 3 is 1, 1. Binary value of 2 is 1, 0. So similarly, these are just replacement of your binary bits for 3, 2, 1, 0. You got this right? How we get 1, 1, 1, 1, 0, 0, 0. I hope you guys have heard about that 88421 thing, the table when we need to just convert it into 8 bit, then for if it's 16 bit we just give 16, then just write the bits there. You know this one, right? If 4 bit, just 421, everyone. So if your value is 1, we can just write 1. If our value is 0, then we can 2, then it will be 1, 0, 0. And if it's 3, it will be 1, 1. And if it's 4, it will be 1, 0, 0. I hope this one everyone know. The easiest table.
Yes, ma'am.
Okay. So these are just the binary bits. Okay. So just let's follow our thing. So what's the thing? We are going to split this output again. Okay. Just right. Split. After splitting, just think like this. So this part will go to your S0 box, and this part will go to S1 box. Okay, this half for S1 box and left half will go to S0 box. So we'll just fed to S boxes. Now see what we can do. Remember our bit 1 and bit 4. So let's see for the S0. Okay, we are going to do the S0 one. For take this part. So our input is 0, 1, 1, 0. Correct? This half. Now remember bit 1 and bit 4 gives you the row. Okay, row. So it's 0, 0. And bit 2 and 3 gives you the column. Column value is 1, 1. So can you tell me the decimal value for this? For
0
zero
and
zero? Yes, correct. It's 0 and column is 3.
3.
Okay. So now you have to see this S boxes. That means row you will follow 0 and column is 3. So go to the S box. Okay. You can number it. So our value was 0 and 3, right? We are doing S boxes. So 0 row is our 0. That means we will look into this row. And column was our 3. That is 1, 10 means 1, 0. So we will put here means output for S box is our 1, 0. Okay. Output for S0 is our 1, 0. Okay, this is our output is 1, 0. Okay, now we will do S1 part. Okay, so here input is 0, 1, 1, 1. Again same, the first and the fourth bit will give you row 0, 1. 0, 1 means 1 and column is this second and third bit. So 1, 1. So it's 3. So we are going to see the row 1 and column 3 of your S box 1. So what's the value here? See, for S boxes, row 1, this is our row and column 3. So it's 1. So our output here, what is our output? Output is 1, 1. Okay, so after S box 1, our output is 1 and 1. Okay, just see this for a while. Up to this clear?
Yes, ma'am.
Okay, so everyone is just following, right? I'm going to clear it again. So can I clear the canvas? Okay, just remember this left half. Okay, later you have to tell me. So after this, what's the step? After S box, what's the step? A step is to now combine these two halves together. Then take these 4 bits into the P4 table and get the result. Okay. So second class case है? Second class, next class कहाँ से?
Ma'am, web tech.
हाँ? Web tech. Web tech class now. You guys want me to finish up to here? It's half done. Still long way to go. Okay, just do up to this level maybe. Okay, we will just finish up to this level. We have done this S2, S1. Now we are going to put it into P4 table. Okay, this is our P4 table. 1, 2, 3, 4. We are going to permute it as 2, 4, 3, 1. So can I clear this canvas? Just remember this right half. We have to use it later. Sorry, left half. Everyone is following me, right?
Yes, ma'am.
So I am going to just clear it. So what's the process? We just need to combine it. What was the output for your S boxes? S0? S0 was 1, 0, I guess. Output of S0 was S10 and it was 1, 1. So next step is to combine it. Okay, combine means 1, 0, 1, 1. So now we need to put it in P4 table. Okay, P4 table input again we can write 1, 0, 1, 1, number it 1, 2, 3, 4. Then output should be 2, 4, 3, 1. 2, 4, 3, 1. Okay, that means 2 means 0, 4 means 1, 3 means 1, and 1 means 1. So this is our output after P4 table. Now step is XOR the output with the left 4 bit of initial permutation. It's going to end in 5 minutes. Okay, I'll just stop here, just do the XOR part. So now we need to do XOR with left half of initial permutation. So it's 0, 1, 1, 1. What was the left half for the initial permutation? IP. Was
0110.
no, it
No,
was 1010, the left half after initial permutation. So we are just going to XOR it. That means it's 1, 1, 0, and 1. This is our initial. Now output will be what? Get the right half of the initial permute, which is step 3, and combine that with the output. So right half means the one which we use to get the EP or P8. See? Initial permutation, right half we put into the EP, left half was unused. Now we are going to combine, just XOR the left half with the P4 and the value we are going to add up with the right hand side. Okay, so here comes the output will be 1101 plus your right half of IP, initial permutation, and the value was 1101, right half was 1001. Okay, this is our output. So after that, what we are going to do, we are just going to just write the output here. 1010, 1 and 1 0 0 1. So after that we are going to swap or switch these two halves. Okay, I'm just going to switch this half. So it's 1 0 0 1 and 1 1 0 1. So this is our initial output, and this value we are again going to perform the FK2. So that means you will just repeat all the steps from step 2. Okay, this is for your task. So again break two halves, we have done it, then swap both halves, which means left half in place right and vice versa. Then after that we are going to take this half once again and start the same procedure from the step 2, and in the end we will just put in IP inverse table and we will get the final cipher, which we will do tomorrow, or if you want to try you can try. I'll share the slides. So basically we have done up till here. Okay, swapping we have done. So after generating this we are again need to do the same process, split, then put it in EP and all. Okay, I'm going to stop sharing. I know it's very long, but yeah, it's good that you should know it. And if exam is online, so of course I cannot give this whole thing. But if offline exam, then yeah, you might have to do it. But the thing is, I'll provide all the tables. Okay, thank you.
Thank you.
See you in next class.